Welcome to Math with Mrs. Bibb. Today we will be talking about binomial expansion and Pascal's triangle. We're going to be expanding binomials. And when you're expanding binomials, I want to show you a plus b to the second power. Those are the largest, I believe, that you've done in previous math classes. And we were always told to write two of them and distribute a times a plus b times a plus b. But there's some really cool things that happen with expanding binomials. One of the first things that you know is that there are n plus 1 terms in the expansion. So I tell students the first thing you're going to do is add 1 to your exponent. That's how many terms will be in your answer. The second thing that we know is that n is the exponent of a in the first term and b in the second term. Next, in successive terms, the exponents decrease by 1. I'll explain that in just a minute. The exponents of a decreases by 1, and the exponents of b increases by 1. The sum of the exponents in each term is n. The sum of the exponents in each term is n. And the coefficients are symmetric. So the coefficients of the expansion, or the product, coefficients are symmetric. Next, Pascal's triangle. This triangle is a triangle of numbers in which a row represents the coefficients of an expanded binomial. Each row begins and ends with 1. So let's draw Pascal's triangle. The first row is just 1. The second row, 1, 1. The third row, this is where it gets a little complicated. The third row begins with a 1 and ends with a 1, but it has 3 terms. How you find that third term, this term, is the sum of the 2 previous terms. Looks like a little heart. 1 plus 1 is 2. So you add those 2 terms together. The fourth row begins with a 1 and ends with a 1. And how you find, how you find this term is you add 1 plus 2. That gives you 3. And the next term is 2 plus 1, which is 3. The next row, the fifth row, starts with a 1 and ends with a 1. To get this term, you add 1 plus 3. and that's 4. To get the next term, you add 3 plus 3. That gives you the next one. And that's 6. To get the next one, hopefully you notice each row is increasing by 1 as well. So to get the next term, you add 3 plus 1, which is 4. See if you can write 2 more rows of Pascal's triangle. I'll do one more, and then maybe you can do 2 more rows of that, and then we'll check that in class. The first row starts with the 4, the next row starts with the 1 and ends with a 1. This term is 1 plus 4, which is 5. The next term is 4 plus 6, which is 10. The next term is 6 plus 4, which is 10. The next term is 4 plus 1, which is 5, and then 1. So see if you can come up with 2 more rows of Pascal's triangle. And hopefully you notice the numbers are making a triangle. In the textbook, you're going to find that the binomial theorem includes combinations of numbers, and that's when you use factorial. It's very complicated, and I don't mind to introduce you to factorial if you've never seen it before. You have to do, let me see, for example, 2 factorial divided by 1 factorial times 4 factorial. And all that is, if you don't remember factorial, is 2 times 1. It's repeated multiplication with whole numbers. 1 times 1 times 4 times 3 times 2 times 1. This is, let me highlight. This is 4 factorial. This is 1 factorial. And this is 2 factorial. And you just multiply and simplify. So my numerator would be 2. My denominator would be 1 times 1 times 4 is 4. 4 times 3 is 12. 12 times 2 is 24. So the product, or the quotient I should say, of 2 factorial divided by 1 factorial times 4 factorial is just 1/12. And it gets really complicated if you want to look in the textbook. Page 249, you're welcome to look at that, but I'm not going to use the entire binomial theorem. I'm so sorry. There is an easier way to go about finding the expansion of a binomial without completely doing those combinations with factorial. So we're going to just carry on, and we're going to do an example, and that example is W plus L, and the L's cursive to the 6th power. This is how I teach students to do it. The first thing you do is find how many terms is going to be in the expansion. So when you look at this exponent, add 1 to this exponent. So I'm going to use a different color, and I'm going to put plus 1. So I know that I'm going to have 7 terms in my expansion. 1, 2, 3, 4, 5, 6, so sorry, I had to go to the next line, 7. Okay, so let's start with this first term. We're going to start with W. Start on the left, since your variable's on the left. W gets raised to the 6th power. And just like we wrote before, W decreases for each term. The first term decreases, W to the 5th, W to the 4th, W to the 3rd, W to the 2nd, W to the 1st, and W to the 0. And then let's go to L. Since L is on the right, I start on the right. L is raised to the 6th power. Then L is raised to the 5th power. Then the 4th power. Then the 3rd power. And the 2nd power. And the 1st power. And the 0 power. And then the next thing you have to do is find the row in Pascal's triangle that has 7 terms. 1, 2, 3, 4, 5, 6, 7. Looking at Pascal's triangle, one of the rows that I need is one of the ones I asked you to fill out. So you get to check that one. We'll check the next one in class. Hopefully we won't need the next one. So the row that has 7 terms is the next row. 1 here, 1 here. 1 plus 5 is 6. 5 plus 10 is 15. 10 plus 10 is 20. 10 plus 5 is 15. 5 plus 1 is 6. Now what you do with that is these numbers are the coefficients of each term. 1 is the coefficient of the first term. 6 is the coefficient of the second term. 15 is the coefficient of the next term. 20 is the coefficient of the middle term. 15 is the coefficient of the next term. 6 is the coefficient of the next term, and 1 is the coefficient of the last term. So where we wrote down that the exponents are symmetrical, you can see here 20 is in the middle, 15 is on either side, then 6, and then 1. So that happens with Pascal's triangle. And now we're going to simplify that 7 terms into the expansion of w plus L to the 6th power. So 1 times w to the 6th times L to the 0 is just w to the 6th, plus 6 times w to the 5th times L to the 1st is 6w to the 5th, plus 15 w to the 4th L to the 2nd, plus 20 w to the 3rd L to the 2nd, plus 15 w to the 2nd L to the 1st. L to the 4th power. Plus 6 w to the 1st L to the 5th. Plus, I thought I could fit all the terms on one. Oh, maybe I can. Hold on. Plus L to the 6th power. So you can sort of see my 6 there. That is the expansion of w plus L raised to the 6th power. Now I'm going to expand x plus 1/3 to the 4th power. Okay, let's go through. First thing I'm going to do is add 1. So I know in my answer I'm going to have 1, 2, 3, 4, 5 terms, because that's how many answers are in the expansion of x plus 1/3 to the 4th power. I'm going to start with x, and I'm going to put x to the 4th power, because that's your degree. Then x to the 3rd power. Put little dots for times. Then I'm going to put x to the 2nd power times x to the 1st power times x to the 0 power. Then I'm going to go to the next term, 1/3. I'm going to start on the far right. 1/3 to the 4th power times 1/3 to the 3rd power, decreasing from here, times 1/3 to the 2nd power, times 1/3 to the 1st power, times 1/3 to the 0 power. And then I'm going to add in Pascal's triangle the row that has 5 terms. So 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. So that's the row I need. I need this row. And I'm going to put those coefficients here. Times 1, times 4, times 6, times 4, times 1. And now I'm going to do the math. I'm going to do my exponents of the green ones, the fractions. So let's go through and do that. So this one's going to be 1 times x to the 4th. This one's going to be x to the 4th plus 4 times x to the 3rd times 1/3, because that's 1/3 to the first power, plus 6 times x to the 2nd times 1/9. 1/3 times 1/3 is 1/9, plus 4 times x to the first power times 1/27, plus 1 times 1, because x to the 0 is 1, 1 times 1, times 1 over, I think that's 81. 1/3 multiplied by itself 4 times. Now I'm going to actually do the math. The first term is just x to the 4th. 4 times x cubed times 1/3 is 4/3 x cubed, plus 6 times x squared times 1/9 is 6/9 x squared, which is 2/3 x squared, plus 4 times x times 1/27 is 4/27 x, plus 1 times 1 times 1/81 is 1/81. And that would be the expansion of x plus 1/3 to the 4th power. Now for my next question, I want to do 2c minus 6d to the 3rd power. And it's just a little bit different with the subtraction sign. So first thing I do is still add 1, and I know I'm going to have 4 terms in my expansion. 1, 2, 3, 4. Now, the next thing I'm going to do is I am going to start with 2c, start here, 2c to the 3rd power. Then I'm going to have 2c to the 2nd power. Then 2c to the 1st power, and 2c to the 0 power. Then next I'm going to have negative 6d. So I'm going to start on the far right. I'm going to have negative 6d to the 3rd power. Then negative 6d to the 2nd power. And negative 6d to the 1st power, and negative 6d to the 0 power. And then I'm going to write out Pascal's triangle. I need the row with 4 terms. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. So then I'm going to put those as my coefficients. 1 times 3 times 3 times 1. And now I'm going to do the math. 1 stays there. 2c to the 3rd power is 8c cubed times 1. Anything to the 0 power is 1. Then 3 times 4c squared times negative 6d. And then 3 times 2c times positive 36d. Then 1 times 1 times 216 negative 216 d to the 3rd power. Now let's do the multiplication and get our expansion completed. 1 times 8c cubed times 1 is 8c cubed, plus 3 times 4 times negative 6, oops, I'm going to undo that plus, minus 12 times 6 is 84, 84cd. Then 3 times 2 times 36 is 36 times 6, 216, positive, 216c times d. And then I've got 216 times 1 times 1, and 216 is negative d cubed, 216 d cubed. That's the answer to this one. For example 4, let's do another one with fractions. Let's do 3x plus 1/2 y to the 4th power. So I'm going to have 5 terms in my answer. 1, 2, 3, 4, 5. I'm going to start with this term on the left. So 3x to the 4th power. 1, 2, 3, 4, 5. So I didn't put plus 1 up there, but we did add 1. And then I'm going to have in the second term 3x to the 3rd power. And then in the third term 3x to the 2nd power. And 3x to the 1st power. And 3x to the 0 power. Then I'm going to go to 1/3. No, excuse me, 1/2 y. And I'm going to start on the far left, and I'm going to have 1/2 y to the 4th power. Then I'll have 1/2 y to the 3rd power. 1/2 y, left off on y, to the 2nd power. 1/2 y to the 1st power, and 1/2 y to the 0 power. And then I need Pascal's triangle that has 5, 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. I think that's the row. So multiply by 1, multiply by 4, multiply by 6, multiply by 4, multiply by 1. Now let's do the math. We'll do the exponents first. 1 times 3 times 3 is 9 times 3 is 27. 81. X to the 4th times 1. Anything to the 0 power is 1. Next, 4 times 27x cubed times 1/2 times y. Then 6 times 9x squared times 1/4 y squared. Then 4 times 3x times 1/8 y cubed. And then 1 times 1 times 1/2 to the 1/2 y to the 4th power would be 2 times 2 is 4 times 2 is 8 times 2 is 16. So 1/16 y to the 4th. Now let's do the multiplication there. The first one is 81x to the 4th plus 4 times 1/2. I'm going to do this multiplication first. 4 times 1/2 is 2. 2 times 27 is 54x to the 3rd. 6 times 9 is 54. 54 times 1/4. Oh, it doesn't work. So it's going to be a fraction. 54/4, which would be 27 over 2. So I'm going to put 27 over 2 x squared y squared. Then the next one's going to be 12 over 8. So plus 4 over 2. No. 4 goes into 12 3 times. 3 over 2 xy cubed plus 1/16 y to the 4th power. For the last one, I want you to give it a try, see how you can do. We will do, I'll try to make it not too big. Let's have you try 4a plus 3b to the 4th power. So give that one a try. If you miss it, it's okay. Just see if you can figure out how many terms you're going to have in your answer, figure out which row of Pascal's triangle you're going to use, and just give it a good old try. Have a wonderful day.